Hello everyone, my name is Shyamji and today I am going to solve the problem that is a number of good pairs. So the problem statement is that you have given an array and you need to count the number of good pairs, how many good pairs appear in this array. So a pairs is called good pairs if I less than j and nums of I is equal to the nums of j. So if I see in the first test cases, like the test case is 1, 2, 3, 1, 1, 3. So index of it is 0, 1, 2, 3, 4, and 5. So I can make a pair by using index 0 and 3 because the element is at its index 0 is and the element is at index 3 is equal because it is 1 and it is also 1 and 0 is less than 3, so I can make a pair, so it will be 3 0 comma 3 and another good pairs I can make using index 0 comma 4, so I can use these in two index, so it will be also 0 comma 4 and I can use index 2 and index 5 because here is 3 and here is also 3. So I can say that 2 and 5 also be a good pair and I can use index 3 and index 4, so it will be 1 3 comma 4, it will be also be a good pair. So what approach can I think in this, because I can fix an index, like if I fix a pointer here and check any index after this index at which the value is equal to this and because I'm checking after to this element, so our j always will be greater than I can say that. So if I write this test case again, so so let's take this test case again. So this will be 1 and 3. So if I pointer to here and start our j pointer after the I pointer, so our j pointer will be here and so I will check if the element at index I is equal to j. No, so I cannot make a pair, so I will move j pointer to the next item, so it will be this and I will check if our jth index element is equal to the ith element index as index element. So it is also not because it is 1 and it is 3. So I cannot make a pair. So I will move j pointer to here and say this one and this one is this one and this one is equal. So I can make a pair. So I will increase this count. So initially count is 0. So I found the index. So I will increase this count by 1. So now I will move this j pointer. So j point to here. I will check our this index element and this index element is equal. Yes, it is equal. Then I can increase our count. So it will be 2. And now our j pointer will go here and I will check if it is equal. No, it is not equal. So the second loop will be end. So our first loop value will be increased because initially I was pointing to here. Now I will point to here and I will start j. So now I will point to here and I will start j from here. So I will check if 2 is equal to 3. No. So I will check here if 2 is equal to 1. No. I will check here if 2 is equal to 1. No. I will check here if 2 is equal to 3. No. So I will increase our right the pointer to, like I pointer to here. So now I will point here and J will point after the ith element. So it will point here. Now I will check 3 is equal to 1. No. So I will check 3 is equal to this one. No. So I will check 3 is equal to this 3. Yes. So I will increase the count by 1. So it will be 3. And now this loop will be end. So I will move our I pointer to the next element. So now I will point to here. So I will check 1 is equal to this one because j is here. So if the j is equal to this, so I can say that our count will be increased. And now I will check that this 1 is equal to this 3. No. So I will move the I pointer because loop is in. So I can say that our now I is pointing to here. And now I will compare with the j. So our 1 is not equal to 3. So I will not increase. Now our I is pointing to here, but I'm starting the j pointer after the I pointer. So there is no any element in there. So I can say that our count is 3 and I can return it. So this is the approach we are going to use here. So after I need to write the so initially I'm creating a variable that is count 0 and creating a loop that is I start from 0. Initially I will start I from 0 and I will go less than n because n is the length of the our array, and I will increase I will start another loop j from after the I, so it will be start from I plus 1 and j will go to the next element until it is in the array range. So j also will less than n. So I will increase j and here I will check if the nums of I is equal to nums of j because I know I am starting the j after the I because if j pointing to the first element, so I will start j from the second element. Then our I always be less than j, so I don't need to check it here. So I can just say that our count will be increased by 1. Otherwise, don't do anything. Just move to the next element. So this condition will execute. This statement will execute and they will be go to the next index, and now the condition will again check. So this loop will end and this loop will end and I can just return the count. So this will be my brute force approach. So let's think the time complexity of this approach. Because I am using a loop that is run from 0 to n, so it will take order of n, and another loop that is going from 0 1 to 1, because if the I is equal to 0, then j will start from 1. So this loop is inside the this loop, so it is also taking order of n complexity. So because it is inside to this, so I can say that we will take order of n square, because if this loop is running from 0 to n, so it is n, so another loop will run for it from n minus 1, because I will start with the after one element, so it will be run n minus 1. So if I multiply it, so it will be n square minus n. I can avoid this n because it is lesser in comparison to n square. So this will be my time complexity, and here I am not using any extra space, so I can just say that our space complexity will be order of 1 in this approach. So this approach takes order of n square complexity, so it will not be good because this is the brute force approach. So what another approach can I think in this problem? So because I can just make a formula for it, because I know if there is a duplicate element like 1 1 1 1, so I can make the pairs by using it this one can make pair with it and with it and with it. So I can say that, and this will make pair with this and with this, and this will make pair with this. So I can say that if I we have n element, and that element can make pairs with the n minus 1 except it. But because I didn't want to use any pairs twice, so I will divide it by 2, because this statement like this one make pair this one and this one, so this one can make pair 3, and for this one. So if I use same approach here, so this will make pair with it, and with it. So it can also make 3 pairs, and same for it, this one, and same for this one. So I can make 12 pairs. But because I am using the pairs in the previous, because for this one I am again using this pair, and for this one I am again using this and this pair, and for this one I am again using this. So these pairs I am using twice for every element, because for this element I am using this pair, and for this element I am using this. So it is twice, so I can divide it by 2. So now I can make the number of good pairs. So let's think with this with another test case. If the test case is one like same case we have given above, 1 1 1 1. So our one encounters 4 times in this array. So I can say that one encounters 4 times in this array. So I can make good pairs by using one, because I am not using any pairs twice. So this will be 4 into 3 divided by 2. So it will be 12 divided by 2. It will be 6. That is my answer, because we have found a formula which solve this problem. So let's take another example. That was our third test case. So it is the third test case was 1 2 3. So one is counters the 1 times, 2 is counters 1 times, 3 is counters 1 time. So if I calculate for this. So it will be 1 into 0 divided by 2. So it will be 0 because I will take the floor value in this. So for this one, 1 in this 2, 1 into 0 and divide by 2, it will also be 0. I cannot make here because if any element is given single time, so I cannot make pair of it with someone because there is no any other element which can make pair with it. So for 3, 1 into 0 divided by 2 will be 0. And if I sum up all this, so I will found 0, and that is my answer. So I can try run with the first test case of this approach. So it is 1, 2, 3, 1, 1, 3, and if I use this approach, so 1 counts as 3 times, 2 1 times, and 3 2 times. So by using this one, how many pairs I can make, that is good. So it will be 3 into 2 divided by 2. So I will get 3, and for this I will 1 into 0 divided by 2. So I will get 0. For this 3, it is a 2 into 0 divided by 2, 2 into 1, 2 minus 1, 2 into 1 divided by 2. So I will get 1, and if I sum up this, so it will be 3 plus 1, that is 4, and this is our answer. So I can use this approach also in this problem. So I can use a hash map for the element because in hash map I can make a key a single times, and there is no range of element because element can become twice, and there is no any order of the element that like the element 1 is also present, like 1 is also present in the array, 2 is also present in 3 will be the also present in the array. So if I use the array, so I need to find the greatest index that can be used in the our array. Like there is a greatest element is 3, so I need to make an array of size 3 plus 1 so that I can count 3 at that index. So our array will not be the good for this problem, and because there will be some like 1 3 and 5 I need to count, so I will make an index array of length 6 so that our 5 index come in this array, and there will be like our 0th index will go waste, and 1st index in use, 2 index always waste, 3 index will be in use, 4 will be wasted. So which element is not occur in this range, so that index will be wasted. That's why I will use HashMap in this approach, because which element encounter I will count for that, not which is not in the array. So let's start with this pseudo code. So in Java, I will create a hash map. Integer, integer. give the name to it, frequency, and no, 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 and I can start a for loop by which I can count the elements. So frequency of element. So I will start a loop that is I start from 0, I less than n, I plus plus. N is the length of our array that is given in the problem. So I will count that the frequency in frequency map you need to put num of I, and if it is already available in this array, so you can just get the value of that, and if it is not already available in this array, so you can start with 1. So get our default nums of I comma 0 plus 1. So in this line I am putting the number if it is not available in this array, so it will set the value of the nums in the frequency map, and if it is available in this array, so it will get the value of nums I that is already present, and in that value it will add 1 and again manipulate the value of that nums I by this value which will be calculated here, and if it is not available in this, so it will get a default value that is 0 and 1 to add 1 to it, and again set to the nums I. So if there are any element like here is 1 and 1 and 2, so 1 encounters first time, so it is not available in this map, so it will get the value of this as default, so it will be 0, and but if it is a first time encounter I want to set it by 1, so I will add 1 to it, that will be this, and if it is already available in this array because this 1.2 like value is 1, and now for this one I will check if it is already available in this map, so I will get the value, so value of this is 1, and now currently I am found this one, so I will add 1 to it, so that this method is work like this. So now I can start that which element available in this map, so I will calculate for that every value of the map. So I will start a for loop that is and get a key set of that map value. So frequency dot get key, sorry, key set. So it will give a set of keys because keys will be unique. So it will give a set of unique, and I can just say that get the value of that key. So the value will be for that key will be frequency dot get key. So I by this way I will get the value of that key, and now I am calculating the pairs. So pairs will be previous pair plus current pair that I will calculate by using this formula, that is val into val minus 1, divide it by 2. So for the current element, I will calculate the pairs by using this formula, and I will add to the previous pair. So because initially our pair is empty, that means that there is no any pairs I found, so it is 0. So now I will return pair. So this approach uses a hash map. So the space complexity of this approach will be order of n, because if there is all unique elements, so it will take that n space, because I have all elements in the array of n length unique. So this will take order of n space complexity in worst case, and I'm using a for loop from 0 to 1 here, so it will take order of n, and here I'm using how many unique elements in the array. For that, because a frequency dot key set return a set of unique keys that is present in the frequency map, so it can be in worst case order of n, because if there is all unique element in the array, so it will be order of n. So the overall time complexity will be order of n, because by spreading with this will be goes to 2 of n, and in for the time complexity we cannot consider the integer value, so I will avoid it. So our time complexity will be order of n for this approach. So this can be also approach. Thank you.